Alright, here we are, back out in the garage, Sunday morning, got my hoodie on. It's damn near June, 45 degrees outside right now. This weather in Minnesota has been really interesting this year so far. It was 88 degrees a few days ago, very humid, and today is going to be a high in the low 60s, starting out very cold, so I got the hoodie on until I get working and get warmed up here. But this is where we left off yesterday. We got the top 1 3/4 inch tube bent to shape, ended up going with 6 bends on it, and then we attached it to the frame rails with some 1 5/8 and then bent up the top hoop there out of some 1.5 inch. Today we're going to use some 1.5 inch to connect down to the frame rail, and we'll do that up on both sides. Then we're going to use some more 1.5 inch to make a bottom hoop that's going to be on the same plane as this, so they'll kind of come down and protect the radiator a bit there. And then from there we're going to have some tubes coming down at a diagonal to meet up with the hoop after the bend. That's going to get filled with a bead rolled and dimple dyed aluminum panel, and then we're going to make some tabs to mount up our Hella fog lights, and we're going to make some brackets to mount up the factory turn signals. I think I'm going to kind of mount them back here recessed a little bit so that they're not up in kind of part of the front bumper. Then we're going to take our factory tow hooks, clean them up, weld them to the frame stubs here. At that point, all that will be left to do is use a Sawzall and continue this line, cut the end of this off. We'll make a little piece of metal to weld in for the cap. Then it'll be time to throw some paint and call it good. Before I start working on the side piece here, I'm going to trim off this extra part of the inner fender. I'm going to trim off, well, I'll have to see what this inner part mounts to here, but I'd like to trim this off and get it out of the way. Alright, so I went ahead and trimmed the inner fender, the little plastic piece here, and I trimmed the mount that used to come down. Now it's time to bend up the next tubes. This is going to be, besides this top tube probably, the single hardest tube to bend and have look aesthetically pleasing. It's going to come diagonally down. It's going to mount basically in line with this, so it'll be a little more inboard, kind of towards the core support mount here. We'll mount the tube around here, and it's going to come up diagonally and make a bend to match this bend. We want this the center line of the radiuses to match up pretty well. So it's going to come up at a diagonal, bend around the corner, continue up, and I want it to intersect with this shallow like 12-degree bend that I put on here. So it's going to start right about on the bend center, come down, bend, come down, and in. It's going to be a little bit of a complicated piece to make. I'm also thinking it might look a little bit better if it comes up, it bends here, and then instead of just intersecting kind of like this, if it actually has a slight bend right here, so that it kind of kicks up and mimics the fender, because like I said, this is going to be cut at a little bit of a slant here, and so if this tube follows that same bend, or follows that same angle and then bends, I think it's going to look nicer. So this tube will have 2 bends in it. There will be a twist between the bends. The notch is basically going to be into the bend up here, and then we're going to have a angle to cut down here. So it is going to definitely be the most complicated piece of the entire front bumper. So I'm going to first take a measurement about the overall length, and then I'm gonna figure out a few angles that we want. I kind of think that the first piece is probably going to be a throwaway, just because, like I said, between the first bend and the second bend, there's going to be a twist. We're going to try to nail it the first time. I may actually end up going from the frame rail towards the end here, because I can cut the angle into here, get the tube coming up, then I can line up the bend to be to line up with this bend and get that nailed in, and then that will make it a little bit easier, I think, to figure out the last bend. Unless I leave the tube extra long, the second bend is going to have to go from the outside in. Gonna have to grab the tube here and bend it that way, which isn't the most ideal. It's a little more complicated to pin down the distance between the bends. As you saw yesterday when I was bending, you need a certain amount of leg in that follow block to use as leverage to bend it, otherwise it's just not going to work. So bending close to the end of a tube, you have to grab this part of the tube and start bending it, otherwise there's just not enough leg, like I said. So I think rather than keep talking, I'm just going to grab a piece of tube and we will start making something happen. Alright, so I got a piece of scrap here that's going to be plenty long. This is 1.5 inches. Maybe, I don't know, 063 wall. Maybe it's not quite that thin. Just going to start kind of looking at the angle we're going to run here. I want this bar to come out parallel with this bar, make the bend be parallel with this bar, and then swoop up into it. Like I said, this is definitely going to be the most difficult bar that we're going to make. I see one problem. The original bumper mount, this tab sticks off a little far, so why don't I go ahead, give that guy a quick chat. Alright, we got that out of the way now. So this is going to come up, match that angle, which needs to come out quite a bit to do so. So right about there, it's going to come up. I want it to come up maybe about like that. So I'm going to use my angle finder, and we're going to find the angle of the slice that we're going to take. This is kind of imprecise right here, but looks like we need to go just a little bit steeper. I'm going to transfer this over to the well saw. Bring this back. All right. Let's get this angle set. Right there, like that. Alright, that's set. Let's grab our tube here. Let's take a chop. Alright, we got our angle cut in there. I'll take a deburr tool, deburr the inside carefully. These things can be very dangerous if you're deburring and you slip off. This thing will slice you right open. I know because it's happened to me. I tend to be a little bit of a clumsy person. And so I'm always trying to be extra aware of ways that I can hurt myself to try to avoid that. Alright. I'm just going to hold this up, do some eyeballing, set it flat against the side, rotate it till the angles are parallel. Needs to angle a little bit more. Right there, it's parallel. I like the angle that it's coming up at. It is inboard of the top tube, because I kind of want it to be on the center line of the down tube here. If it sticks out up front, to me it just looks a little goofy. I like things kind of being in the same plane. So let me get this thing here squared up again as much as I can. And I'm going to take my marker, get this thing square as I can. And I'm going to make a mark on it and on the frame rail so it's easy to line back up, so I'm not always having to eyeball it and fight with it. So now I'm going to look at where this bend start is, and I'm going to go straight down, and I'm going to mark the tube. Not the most precise way of doing it, but you're going to want to line up that bend there. I'm also going to mark the top of the tube, what I perceive as the top of the tube. I'm going to mark that. And now we're going to want to do some thinking and figure out what plane we're going to want to make the bend on. The tube is recessed. Like I said, it's on the same plane that this is kind of creating, but I want it to end up being parallel or on center when it meets this bend. I don't really want it to come from the side too much. So this first bend is going to be pretty important, and it's going to have to be on the right plane so that this angle remains flat to the surface that it's going to weld to. I think we're just going to rock a bend. So you can see I marked where the start of the top tube bend was, just followed it vertically down and marked that. This is what I think is the top, the vertical point, the tangent of the tube compared to the twist of the notch where it needs to be. So this will be our intersection here. This is where we'll line up the die and we'll make this vertical, and that's where we'll start the bend. The bend will go on this side, and the bend that we bent yesterday, per my notes, was 50 degrees for this bend right here. So I'm going to set this at 50 degrees again, hold this up, and see, since it's coming upwards too, this bend is going to need to be maybe a little more. Probably not though. If I can get this parallel here, kind of running in the way of a bunch of stuff, unfortunately. But if I can get this parallel coming up how I want it to, it looks like we're going to need just a slight bit more bend. But we will start bending this. Like I said, we're going to treat this as scrap, knowing that it's probably not going to work out, that we might need to chop it and shorten it or lengthen it, adjust the twist between the two bends. But once we get that squared up, we can then take measurements off of that to transfer to the real piece. So let's get started here. Alright, so we got the bend start that we found lined up with the start of the die. This die is nice. It's got this line right here. That is the bend start. And then we found our vertical tangent there. So we're lining that up with the die. Tighten the clamp down. Get the follow bar moved up. Leave a little gap. Plug in our air, and we are going to make a 50-degree bend, but we want to bend it a little further. I'm going to mark this at 54. How about 53? We can always do a little more bend after the fact. And I won't be able to use the measurement. We bent the 50 degrees on this 1 3/4, and I took the measurement based off of here and the little guide there. But since that's an 1 3/4 tube with a different radius die, that measurement really means nothing to me. I can't use that, so we'll bend this using the protractor, then we'll take a measurement, and so we will know that for our final piece. Alright, so we have our bend. I marked the little indent here, so if we need to bend it more, we can line it back up. I've made the mark along the follow tube here. There is going to be another bend, and we'll use that to be able to measure for our twist, because the two bends are going to be on different planes. Now I will take my little ruler here. We will measure what this bend turned out to be to the closest 16th, I suppose. Let's bump this just a bit more so that we have a full 16th. There we go. That is right at 2.5. So I'll mark that down on our little sheet here. 2.5 for the bend. And we'll see how that looks here. So we'll line this up with the marks that I have made. There's some wiring kind of in the way here. Let me see if I can fish that out of the way. We'll line that back up with the previous marks I made. And we'll see how this is looking. Is it parallel with the top tube? very close? Close enough? Is it looking like I want it to look? How are the bends lined up? Take a look at it from a few different angles here. Yeah, it's looking pretty good. The bend lines up all right. I think it would be nice to use some tape to tape it in place. There we go, close enough. The struggle is real. All right, so now I want to check the parallelism here. That is not looking very good from this angle. Needs to go in more. I think that's just because of how I have this supported. That angle's not looking too bad, so I think we might have bent it a little bit too much. As far as the bends being on the same plane, it's actually not doing too bad. They're a little different radius. I want to look at this from a few angles here and see how we're looking. Get back from a further distance. I'm actually liking it. We're going to roll another bend right up here to meet up with that. So I'm going to use my bend protractor again to kind of visualize the bend that I'm going to want. The notch is definitely going to be in the middle of the bend. Let's get that down and kind of squared up and see what angle we're going to want to do. Looks like we're going to want to bend about a 45-degree bend there. And so unless I leave the piece extra long for that leg for the leverage on the follow bar, we're going to have to bend this one from the end inward. So we're going to want to figure out where the bend start would be if we were bending from the inside out. We want this to line up right with that bend there, be parallel here. So that right there is where the bend start would be. Now we need to add, it looks like about 4 3/4 inches to this to figure out where the bend start would be going from the outside in. So I'll take my little stubby measure here and we'll add 4 3/4. And that's going to be where we want the actual bend start to be. And then we want to find the bend plane for this one, assuming that the bend is less so that these two are going to be parallel. I think it's actually going to work best if these two bends are perpendicular to each other, which would be really an easy amount of twist between the bends instead of something like 30 degrees, which is the average twist for like an A-pillar bar on a roll cage. This just being basically a 90-degree works out really well, so that mark that we made on the follow bar for this bend we can use as a reference for the next bend here, which is going to be basically 90 degrees, or not basically, is going to be 90 degrees from there. So this is still just going to be a test tube, but I want to go the whole distance with it, kind of, to be able to take the measurements off of it and transfer to the real tube and see if there's any tweaks I want to make to it. When you're doing a front bumper like this, it really is all about aesthetics. You want to make things pleasing to look at. That's why having things parallel, square, perpendicular are a nice way of going about it to achieve that look. So we have our mark for the next bend. I'm going to transfer that bend a little more, or that mark a little around the tube a little more here. And all right. Now I'll bring it over to the tubing bender, remembering that we're bending basically from the end in, so we'll put it in the die this way. That's going to be our bend start there, but we want, actually, so here's one of the limitations with this follow block, is you have a little bit of play here that you can do the twist, but you can't twist this 90 degrees there and have that bend be like that. So in the final piece, we very well might need to start bending from the outside towards the frame rail to get what we need. Now we did mark the other bend if we're going to bend from the inside out, and there isn't enough leg to do that, so that's what we're going to have to do. So let me transfer that mark all the way around the tube here. Oh, come on, you son of a gun. Good enough. So this one we're going to bend from here outwards, but we want to bend it. This is going to be coming up. We want the bend to go upwards. So to do that, pull the bender out a bit so that the tip can overhang. This is going to be pointed down. And we will get the saddle in here. We'll get it clamped on our start line. This will actually work out better for the real piece we'll use. We'll be able to take a little bit better measurements off of there, I think. So now we just want to get the tube perpendicular to the machine. We'll get some slack out of it. Move the fall block out a little bit. And give this a little loosen. And we want this to be perpendicular, like I said. It's going to be easiest to look down the length of the follow block. Oh God, I'm sore. Ow, 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 my mountain bike bruises. And so it needs to twist just the tiniest bit this way. We're going to roll with that. This is just an experiment tube. We're going to bend. We want 45 degrees is what it was looking like. So we're going to set this. Let's set this to 48 for the spring back. This tube is pretty thin wall, so it doesn't have as much spring back as a thicker wall tube. We'll start bending. This bend, the second bend, lines up at 2 1/4. So take the pressure off, and we'll see where we're at with this bend. Now this leg is going to be much too long to get a a real good representation, but I will kind of be able to hold it up here, see if that's the look I was looking for. I'm going to throw a notch in it, why not? I want to mark what is going to wind up being the center line of the notch, which is going to be offset just a little bit. If I can find a damn marker. It's going to be offset just a little bit from the bend itself, because we are lining this up with this bend in the center of it. So we're going to take, I don't know, take a little bit out of that. We're going to notch it pretty close to the bend end. You can just notch through the whole tube, notch through both sides. It definitely works better when you notch less material, so I'm just going to put this in the saw real quick and we will chop it. I just want to take some material off, but you can see we're running into the problem where the saw is running into the bend of the tube here. If we can go in from the other way, which we can since it has a long enough leg, we'll do that, and we will take a chop at it, kind of an arbitrary chop. Like I said, this is just a test piece really. Alright, there's our cut. I think it actually kind of worked out to our benefit. Now we can hold this up, have a look at what we're doing. It's looking pretty good. We will take that notch now. We also need to figure out the angle of that notch, so we will use our angle finder again so that we can set the notcher up to that angle. This is going to be a little bit of an eyeballer here because we are going to be notching on a bend. And call it whatever this is. Let's set up the notcher for what we need. Get some of this out of the way. Oh, Jesus. Get out there. And yeah, remember to connect it, right? Alright, let me grab this. Give these guys a loosen. My glasses on here. We will set this angle. It's going to be handy again just to stick a piece of tube in here, make it easier to square this up. This is not incredibly accurate. Looks like 30-degree notch we're going to roll with. And there's going to be a little bit of, let's see, we want to notch it generally in that direction. So this is on the bend. So that changes the actual angle here. All we're going to really do, this is the center line of the bend. This is what I think the notch needs to be, so we need to make this the tangent there, whatever, I don't know the terminology. And we are going to take a nibble out of this and then we'll be able to adjust the angle of this to take into account the fact that the tube is rolling away. So we'll actually need, this is about 30 degrees. This looks like it's coming at least 10-15 degrees away from what a straight piece would do. So we'll need to add that in. But first we're just going to take a little nip at it, see how it is looking. Now also, since we're notching a little bit past the center line of the radius, this will notch offset, so we're actually going to have to lower down the machine so that puts us back on center. So like I said, this is definitely the most complicated piece in the equation. So we will lower this down until we have it centered. Now this is still going to an 1 3/4 piece, so we are going to continue to use the 1 3/4 tube notcher. I'm just going to eyeball this up generally. It needs to come up a bit, look at it from a couple different angles. It needs to come up just about roll with right there, see how that does. All right, now we'll give her a notch. All right, let's see how we did here. This is just a first cut. It's not going to be the one we want. Yep, and like I said, this is going to need to be steeper, but it's lining up and looking how I want it to. The notch is actually pretty good. It just needs to be steeper. But like I said, this is more of a proof of concept. That's not so bad. I'm going to roll another notch in it, steeper. See how it looks. I want to get it fit so that I can use some tape to get it in place and then stand back and really have a look. To get it parallel with this and parallel with that from the top looking down, that might be all well and good, but as soon as you stand back, that actually might make it look goofy because it's coming up at a diagonal. So you really want to take a step back, look at it from the front, look at it from the side, the 3/4 angle, look at it from above, below, and really decide aesthetically what is going to be best. We are going to add perhaps 10 degrees on the notch here. It definitely needed a little more angle on the notch, so we're going to add more. We're not going to take much off the front edge, just off the back edge really. You want to line that back up, like that. Now we got to check and see if our height is still good enough. It looks like, since we're doing a little more angle on it, it looks like we need to raise this up a little bit once again. This is kind of a fidgety process, but take a little extra time. Make it nice. I like that. Now this side is probably going to wind up being a lot easier than the other side, because while this can go down, it really can't go up. Actually, that's not really true. I think there's, if you loosen this, the whole assembly can actually go up. There's a little bit of the tube sticking down there. Of course, I didn't have the camera pointed at me. But let's take a notch. You want to be careful when you're notching at a bigger angle with this machine. When you come through, you can run it right into the surface here. I just kind of nibbled at this bolt a little bit. You definitely don't want to make a habit of running it into there. Probably affect the performance in the long run. And these things aren't cheap, so you might as well keep them as nice as you can. So let's go ahead and see how it fits now. That notch is actually, I don't want to say perfect, but it is very good. I actually really like the tube. Let's see if we can use any magnets in combination with the tape to get this son of a gun to stay in place. Hopefully that stays long enough for me to take a look at it from a few different angles. I'm going to show you what I'm looking at here. So we'll take a look from the 3/4. I really like how that flows. If you look from the side here, this angle roughly imitates that angle. This is going to be chopped, like I said, to that angle. That's pretty similar. It has a really good flow to it. The bends line up pretty good. This bend could be shifted over a little bit, but the radiuses are different. So this bend is just going to take up, and it's a bigger tube, so this bend is just going to take up more room. If you look at it, this bend could perhaps be moved over just a bit. So look from the top, this is decently parallel here, and then from here you can see that it's not. It definitely goes inwards a bit. Looking at it from this direction, it really doesn't look bad. Again, from the front, I think that looks pretty good actually. I like the flow of it. Hard part is going to be replicating one on the other side, but certainly not impossible, just will take some extra careful thinking there. I actually really like this. I think this is going to be a final piece. I think I could make it marginally better by shifting this bend over a little bit, but honestly, I don't know if that is going to be worth it. I haven't done much tubing like this in a while, and I very well could cut another piece of tube, make the changes, and aesthetically it wouldn't look as nice. I really like the way this looks. You can see from this angle it flows up and into the over fender quite nicely. It has a pretty pleasing look to me. I'm gonna roll with this. Now the next step is to grab another piece of tubing and to replicate this. So I still have the bandsaw set up to make that angle. So the first cut we will do is to make that slice, and then we know we'll be able to tell the distance from there to the first bend, and I can find the tangent from the plane, perpendicular to this bend, and take that all the way back on this piece, and then measure the twist between this and the bend. And then we know that this bend and this bend are just bent 90 degrees in relation to each other. Honestly, the tube isn't going to be as hard as I'm making it out to seem. Just gotta take some careful measurements here. So why don't I measure the overall length of this, and we will cut one to the, actually we're gonna cut a tube to the length that this was before I started notching, so that we have that extra leg to be able to bend, because remember how these bends are so close together that this runs into the follow block there. So we really need to bend it from the inside out. To do that, we have to have extra leg. So I will measure what this tube was we'll cut a piece and we'll get started. I got another piece of 1.5" cut. I have the slice made in it there with the angle to match this one. So now we need to transfer the marks. We need to figure out the twist and the distance to the bend. So I'm going to find the, using this plane, I'm going to find the tangent here on this piece, and we'll mark it, and then we'll measure the twist from that to the center line of the bend there. So this is just going to be eyeballing it, nothing more. You can get really fancy. You can get a digital level out and you can make it super technical, but you don't need to make it rocket science. Just need to make it look good. There we go. I'm calling that the center of my tangent there. Now, another cool thing about the Mittler Brothers bender is you got this follow block. I can put the tube in it, and this just works as a nice way to make a straight line, and I can continue that up the tube. I know I'm blocking it, I'll show you. So I found the peak, or the tangent there, of this slice, and so I marked that all the way up. This is the original bend start. This is the center line of the bend. This is the distance of the twist. So now we are going to find the tangent of this one. Tangent might not even be the right word, I don't know. It's just the word I like using. You can correct me if I'm wrong. I don't claim to be an expert. I just do what I do and learn as I go. Alright, so I'm going to say that this is the top of our tube. Yep, good enough. Let's use the follow block to extend that mark all the way up. So I'll get that set in there, and then we will mark that up. There's our line. Here's our other tube. Now this is going to be opposite, right? This is the other side. So if you can see, let me get this down a little bit. So you can see our two tangent lines here. This bend is offset in this direction from it, so the bend that we are going to make is going to be offset in the other direction. Now I'll line up the ends here, get those lined up, squeeze the pipes together, and then for the bend start, it's really just as simple as transferring over that line. And we'll continue that on just a little bit. Now, we want to measure the distance from the twist to the bend. I'll do that with this tape measure. It is, if you go on the center of the marker, it is just shy of 5/8 of an inch. So now we are going to do the same measurement over here. We're going to put it on the center of the marker. We're going to go over to the 5/8 and we're going to do it just shy. So this is going to be our center line for the bend. This is going to be the start of the bend. We want these to be equal and opposite. So this is going to bend in that direction. And so now we can put the tube in and we can start bending. Now this is where this bender's handy, because these marks are actually 180 degrees from where they need to be if I was going to keep the die in the same orientation as it was before. but that would be a little bit harder to find the marks on. So all I'm going to do is flip the die, and then we can use the marks that we made. So I'll just take the pin out here, flip the die, put it back in, close the machine, make sure the pin's in good, and now we can put this in, and we'll be making the bend in the right direction that we want. Now, need to make sure that this is the one that we're going to bend on. That was our tangent, this is our twist. So, now we will get this situated here in the die. Get it in there, get that bend lined up, get the twist right, needs to go a little deeper in the die here. Get that twist where we need it, and there we go. Now let's snug up the machine. And we are going to bend this to 2.5 inches, and that will replicate our first bend over there. Alright, I marked the die, didn't need to. We know what the bend is, we're not going to bend it anymore, it's just a good habit to get into. Also, yes, it is extremely dangerous to be leaning over the machine while you're bending and taking your measurement. That's a risk I take. I wouldn't recommend it. I've used this machine for hundreds of bends. I always make sure that the saddle clamp is secure, I make sure that the pin is in correctly, and this tubing is nothing for this machine. It rolls through this stuff like butter, so I'm not too concerned. I'm sure there's some safety freaks out there that are cringing every time I do that, but my choice, I'll live with it. Now let's take this out of the machine here, and we will check this. We'll lay these out. You can see that these bends are equal and opposite there. Pretty damn close. These bends are equal opposite. You can see the saddle clamps line up and everything. So now we need to figure out the distance here for this bend. Good way of doing that is really just eyeballing. So whenever the tube bends, there is a little bit of an undercut, and you can feel it with your thumb. And there's also marks that the machine leaves on the tubing, and so you can carefully find where that undercut ends and give it a mark. Then we'll use our tape here to transfer that mark. Make sure I found the right mark. Use that to transfer that mark up to the top here. And so we will find the end of the bend on this tube. This one is a lot easier to see. I don't know if you can see that, but right here you can see the little bit of mark, and then it goes back to the regular tube. So we'll mark that right like that. I will give that a bit of a transfer to the top of the tube so we can make our mark, make sure everything was nice and square, kind of give that a wiggle around. There is our reference to measure from. Now this is 2 3/4 between bends. So we're going to take this, we're going to put it right on there, we're going to mark 2 3/4. And now we're going to transfer that mark 360 degrees around the tube, making sure that this isn't crooked. Give this a rotate here, line it up again, continue the mark, and finally we will finish it off. This is a great trick. I figured that out years ago and it has really helped me out. You can see we got a pretty nice mark all the way around it. So this is where our second bend is going to start. It is perpendicular to the first bend, so we're going to leave the die reversed in the same direction so that when we put this in and line it up, the tube will come out of the follow block and point to the ground, just like this one did. If the die was in the other direction, it'd come out of the follow block and you'd point it straight up. That's 180 degrees opposite. You're making an equal but opposite tube, and that's how you do it. So, let's get this situated. Let me change you around again here. We're going to need to get the bender moved a little bit so that the bend of the tube can hang off the table. Need to make sure that we are going on the right line. Needs to come a little bit more here. Let's get our clamp on there. Start snugging it up. Let's find our bend line. Let's get it on that line. And now we need to square up the twist here. I'm going to take a little slack off of this. Alright, loosen the clamp just a bit, and I will look down and see how our twist is. We can look, we can use the follow block. We can use the line of the follow block here to look all the way down the tube and then make sure that this is perpendicular. It's looking pretty good. I'll eyeball it from the top where it's just a little bit easier to see. You could use a digital level on this. If this was bent to 90, it'd be super simple. You put your digital level on the follow block, zero it, put it on the side, get your 90. Since this is bent to 50 degrees, it adds just a little bit of element to it, but eyeballs are all we need for this project. Now before I make the bend, I want to hold this up and make sure that we are not screwing it all up. So you can see this one, the bends are the same here, but we want these to bend in opposite directions, which is what's going to happen. So now we will bend this to 2 1/4. Make sure that the saddle clamp is good, make sure that the rolling pin is in. Now one of these days I'm going to get around to just making a little bracket that mounts this permanently, and well, not permanently, so that you can remove it, but Mittler Brothers actually makes a bracket. You unbolt this, and it mounts a digital caliper to it, and that is really handy, and maybe I will get a cheaper digital caliper to modify, but for now, this works just fine. There we are at 2 1/4. Got it at 2 1/4. Mark the saddle here. Why not? Like I said, it's a good habit to get into. One of those days, one of those times you'll forget. And like I said, there's a little bit of play, a little bit of arbitration. That's a little bit of arbitrary movement there. If it's a long bend, like 45 degrees or more, it's pretty easy to get it back in the die, get it back in the exact same position, but there's still a little bit of movement this way that it can go in, and that can introduce a twist into your bend, or kind of like a double bend. So it's really important, if you need to go back and bend it more, to get that thing lined up perfectly. So now let's remove this from the machine. Let me move this back out of the way a bit. Things are getting hectic a little bit here. I usually like keeping a little more organized workspace, but so let's give this a check and see that we bent it in opposite but equal directions. And we have bent up, bent up. So now the last part is getting this notch in this tube. We're going to cut this tube on the bandsaw first, and then we are going to get this notch. Now, if we line up our marks here, we can see that if this is the center line of the bend right here, this notch is 1/4 inch inboard. So the notch on this is also going to be 1/4 inch inboard. So we can mark that as just a rough guide. So we'll take it over to the saw, we'll cut off the excess, and we will set up the notcher and roll the first notch in there. And then at that point, what I like to do is, since this piece, the first piece we made, is already fit how I like it, I will clean it up, clean up the frame rail, and we will tack it in place so that we can use this as a reference to eyeball and to measure off of, to make sure that this one is fitting the exact same. So let's get this thing chapped. Alright, so we got our piece cut on the bandsaw. Now it's time to roll the notch in it. It's going to come up at this angle, intersect with it, so we want to cut more on this side than the other. So this tube is going to be pointed upwards in the machine here, the notcher, whereas the other one was pointed down. That's generally how it goes when you're making equal and opposite parts. If the one bend was pointed down or pointed to the left when you notched it, the other one is going to be 180 degrees of that. Simple way to remember. And I'm going to grab the other piece here just to look at it and figure out the distance from the bend start to where the end of the notch is here. When I do this, lots of times I won't use this end because it kind of gets in the way of measuring. Maybe I'll start on the 4, put that on the bend start so that the tape can lie flatter. And so from 4 inches, lay it flat. It's just under 8, about 1/8 under 8. So we're looking at 3 7/8 from the bend here, from the inside mark of the bend. So let's just make a quick mark of that for a reference. The first notch we're going to take is going to be shy, like I always do, because when you put this much work into a tube with 2 different bends and a angled cut on there, you don't want to mess up and take too much off. So we said just shy of 8, 3 7/8. We're measuring from the 4 on the tape measure. So there's our mark where we want to end up. You know, we're going to cut from the opposite side to that, but after we make the first cut, we'll be able to measure that distance and then just take that off the front so we can make these opposite and equal. So let's give this a choppa. And I also have so you might not be able to see, but this is the center line of the cut, and then that is the offset of where we want to notch. So we are going to put it in, make sure that this is going to be shy of where we want. It's going to be very shy of where we want, I believe. Double check. Yup. And so then we will get the twist right. That's pretty dang good right there. Let's tighten that down. Little extra clamping force when you're clamping on a bend, I find, is necessary. Now we need to adjust the height to get a cut on center. Don't want to go through all that work and notch it off center. So we are going to raise this back up. Probably the whole way here. And see if that is centered. It is pretty good for our first cut. We will roll with it. I want to double check that this is going to end up shy. I think I'm actually going to take it 1/8 inch further out so that we can, if we really screw this up, we'll have plenty of room to work with. Alright, so we'll do it right about there. Get it in, re-square it. It's got to get twisted up just a bit. We'll roll with that. Alright, we're plugged in. We'll take a chop. Now, since we are taking a bigger chop here, this is not a specifically long hole saw, so it's running into itself internally, so I can take this and hopefully break off this bit of tube that's getting in the way, almost here. Can also do this with the angle grinder, but then you risk putting the ding in the machine. So we will twist this until it breaks. Almost there. Come on now. All right. Let me bend that back up. And that should allow us to notch the rest of the way. And now it's time for the hoodie to come off, because it's finally in the 50s today, I think. We'll finish this notch carefully at first. There we go. And you can see we're about 5/8 off of the mark we made as far as the other one. I'll just compare it on the table, show you here. If we line everything up, you can see that they're pointing inwards towards each other, so they're equal and opposite. But you can see how much longer this one is. But what I'm going to do is take it over, and we are going to test fit it. We're going to test fit it and see if we got this notch in the correct orientation. And it looks like we got the twist of the notch correct. So now we are going to put it back in the notcher. We're going to remove this final bit of material. Then we will tack weld the left side in, and we use that as a reference to fine tune this guy. Like I said before, older chassis, sometimes they change a little bit of shape by a 1/16 or an 1/8 of an inch. So don't be too alarmed if the tubes wind up, if the notches on the tubes wind up being, you know, a little bit different. The bumper can still wind up being plenty square if that's the case. So we are going to put this back in here just loosely. I'm going to measure that distance, and whatever that is, that's what we will use on the front side. So that is a 1/2 inch. So we are gonna get this in there, square it up a little better, get that notch rotated the right direction, and that looks pretty good. And then we'll make a touch mark here, bring it back and see if we have our 1/2 inch. That is too much, so we will back the tube out a bit, maybe right there. Check it again, that's looking pretty good right there. Give it another touch. That just makes a little mark on the back side so that you can measure off of, square it up with this mark, and that will be an equal distance of a notch to the other one. That is looking good, but now the height is not where we want it, and we've run out of adjustment on this part of the block, but there is adjustment on this part of it where you adjust the angle. So we're going to note the angle here, just steeper than 40 degrees, and we're going to raise up the platform here so that we get a notch that is on center. So we loosen this up, and now you can see I've never done this before, so I might be completely wrong. But I think that's how this works. I'm gonna loosen this up, and this should slide up and down. Up. So it runs into the little angle finder here. I'm just gonna gently bend that back a tiny bit, and then you can see there's some more distance. So we want to get this centered on that bend. I think right there. Let's give this a tighten and double check. We need slightly, oh, there it goes down, of course. We need slightly more than 40 degrees, and we got to get the height correct. So, see if that is correct. It's going to be necessary to eyeball it from both directions. Looks like it is still a little low. It needs to go up more, not that much, maybe there. Let's get our angle set back slightly more than 40. Let me give this a tighten. Go slightly more than 40. Let me see how the height is now. And that looks like it's centered. Yep. Oh, give this a tighten. And we'll roll the notch in there. Now I want to recheck it. Now that I've done all this adjusting, the tube needs to come back out a tiny bit so that we can nail that 1/2 inch that we want. At this point, we really don't want to screw up this tube at all. So let me get it back in there, and then we will square it back up, tighten it down nicely, and now we will notch. And it's running into the tube again, so this time we're so close that I can just grab it and bend it off like this, come back, nibble off that last little bit there. Alright, now let's compare it to our other tube. Now the other tube has been cleaned up a bit, but if we line up our bend starts here and look at that, that is very close, within about an 1/8 inch. So what we're going to do is we are going to clean up the frame rail in the car, we are going to tack this in place, and then we'll be able to use that as a reference for this. This might end up working, it might end up needing to be chopped that extra 1/8, it might even need to be chopped a 1/4. So let's get this in place, and then we will go from there. Alright, I've got the welder all set up. I got the frame rail cleaned up where we're going to weld the tube to it. We're going to tack in the left side so that we can square up the right side, make everything equal and opposite. And I'm not going to get fancy with any magnets or tape. I'm just going to hold it up. It fits into place where it wants to fit into place. I'm going to put a couple tacks on each end, and then we'll begin working on the other side here. Alright, that's really all we need for our purposes. and the pipe is plenty good. I lined it up edge to edge with the hole in the stub of the frame rail there. That way on the other side it'll be quite easy to reproduce that. I got it generally centered. There's like a little notch here and a little notch here. It's a little above center compared to those notches. So we'll take note of that for the other side. And then this side came up right on the middle of the bend there. Generally flow is pretty good with the fender line. Again, we're gonna chop that off later. I think it looks pretty good from all angles. From here you can kind of see how the curve of the headlight hood fender kind of continues down nicely. It's a general, you know, kind of pleasing swoop. So now the goal is to get the other side to mimic this side. So what I'm going to do, I'm going to take a measurement from the end of this tube to where this tube intersects, because we bent this tube so that everything is equal. The stub on each end is equal. So I'll take this measurement, transfer it to the other side, make an actual mark so we know that's where the end of this tube is going to line up with. I already told you how we're going to square up the bottom part, and so we'll see if the notch that we made is going to work for what we need it. So let me take a quick measurement. Four and a quarter. So we'll go over here. I'll measure in 4 1/4, and we'll make a mark, and we'll transfer it. That's probably the worst frickin' mark I've ever made, but it's gonna work for what we need. So let me grab the other tube. And I haven't deburred this or anything yet because I don't know if we're gonna need to roll a little more of a notch in it or not. So what I'm gonna do is I'm gonna hold it up. I'm gonna put it in place. I'm going to rotate it so that the notch is correct and the angle is correct over here. I'm going to get it lined up with that hole. I'm going to put it a little above center between the notches in the frame rail, and then I'm going to look over here and see where we're at. And that seems to be way off. But if you remember when we compared these two, this one was longer. So I'm going to take a 1/4 inch more out of this notch, and then we'll see where we fit. Alright, so I got this trim to fit. I ended up cutting this to be equal length with the other one, which is no surprise. But then to get it to fit how I wanted it, I ended up taking another 1/8 inch off of this bevel right here. And now it fits. We line it up with the hole in the frame rail, line it up here, get everything all squared. You can see that it lines up right with the other mark. All the notches look good. So I'm going to tack that in place, and then we will finish weld both of these tubes, and then we will begin working on the lower hoop, which should be a much simpler bar than what we've been working on. I'll get this thing squared up with the hole in the frame rail. Drop it down just a bit, right there, and I'll roast a tack. There we go. That tube is in place. I will have a quick eyeball. Make sure we are looking relatively parallel here. Give her one last check here. I think it's good. We are going to start finish welding. Now this is going to be a little bit of a hard weld here with the bracket for the core support. So I'm going to go from the bottom first, weld up as much as I can, then let gravity come down with me, roast it around, then I'll come back up to the top and I'll have that nice weld to be able to tie into. I find that it works better that way for me, to start on the bottom and then go from the top when there's some tight fitment. So let's start welding. And we're getting into an area where I was not very good about getting all of the paint off, but it's going to turn out fine. Now we'll go over the top. You might notice how at first the sound is just a little hollow, I guess you could say. There was maybe a 1/16 inch of a gap on the back side. That's fine for MIG welding something like this. Like I said, it's not a professional race car or anything, and 1/16 is pretty easy to fill with the MIG welder and feel comfortable about it. So now we're just going to roast on the front side here. Alright, I'll show you that weld here. You can see I got all the way around it. Not too bad. Now we will weld this seam. Again, if this was like a roll cage, I would weld like 1/3 of this tube. I would weld 1/3 of this tube, then move to the other side, let it cool down. That's going to minimize distortion, warpage, all that stuff. But this is just a front bumper for a daily driver, so we're not going to stress too much about it. I'm actually going to start the vehicle and turn the tire all the way to the right so that I can have a little more room to see what I'm doing. That will give me a little easier time welding on the back side of this guy. Now you notice a lot of the time I weld downhill. If you're building a bridge, you weld uphill. Anything really structural like that. I'm no welding expert, but I believe that the preferred way to weld, if it's either down or up when you're talking about a vertical joint, is to weld up. I think it's easier to weld down. Gravity's working with you. You get a little less penetration because the weld bead is kind of rolling over on itself. But if you, and it also depends on what you do. If you're just going straight down in a line versus if you're making kind of triangles as you go down, I think if you're making triangles or little half moon shapes, the weld isn't going to roll over on itself quite as much and the penetration will be fine. Again, for something like this, we don't need to get super crazy on it. It's not a bridge. Move this, see it? All right. Show you that weld there. Not too shabby. We got the whole thing. It looks all right. Definitely off my game from where I was years ago when I did this basically for a living, or at least was taking on customer projects and working for various shops out in California during the winter. But that's just a bunch of excuses for my lackluster quality. Now this is going to be a little bit choppy on the backside. I definitely should have done a better job of cleaning up the frame rail. Live and learn. When you are having an issue where you didn't clean up enough, I mean, it's kind of hard to go back. I mean, I could break this off and whatever. You want to start your weld on the clean metal and then push the weld onto the dirty metal, and eventually once you get enough heat in it, it's going to start burning off all the paint, and it'll be all right. So you can hear that popping and cracking. That's just burning through the paint on the first little bit of a bead there. Once it got enough heat in it, it wasn't doing too bad. Again, it's gonna be fine. I'm not worried about it. All right, I'll show you that weld there. Not too bad. Roasted in all right. Now let's get this final weld going, and we'll move on to the next bar. I'm going to, well, I think it works to have the tire out as good as it works to have the tire in here, so we're just gonna rock it. Nope, actually, might as well start the vehicle, turn the tires the opposite direction. Do it, right, do it once. Yeah. All right. Now I just did a little bit of trigger welding there just because hard to move the nozzle around the sheet metal there, and there was quite a bit of stick out in the distance between the tip and the metal you're welding, so it would have been hard to create a puddle and manipulate it in the proper way. So I just basically, some people call it pulsing, but it's really just trigger welding, creating a series of tack welds, and that's a horrible way to weld an entire structure together. But just to make sure that we seal the tubes on the back side, that's going to be adequate. The rest of the welds we're doing as continuous as we can. So I'm going to finish this to the side there, and then we'll roast the whole front. That's a little ugly, but so am I. It's all good. Don't worry about it. I'm not worried about it. All right. And there we go with this guy. Gravity kind of fought me right there a little bit. That's all right though. Can't be perfect every time if you don't do this for a living. Oh, I guess you can, but I can't. It's adequate. It's burned together. It ain't going nowhere. So I think, let me turn the, oh, running into the notcher here. Maybe I have my helmet on. That would have caught me right in the forehead. Let me put my leads away. I don't like keeping all the welding stuff laying on the floor. I have a whole bunch of chips from the tube notcher all over the place, and you want to keep those leads as good as you can so that you're not getting any friction for the feeding of the wire. And you know, spent a lot of money on that machine, so I'd like to have it working the same way it's working now in 20 years. So here we are. Now you'll notice that that tube is filthy. This tube is cleaner. They're from a different source. One has a little more mill scale on it, I suppose, than the other. Once they're sanded and painted, it'll all be the same and well and good.